So yeah, 30 years. So I guess when I think about that, so John and I were involved in this stuff from the very, very earliest of days, like nearly 30 years ago. And one of the jokes I tell is if I'd realized 30 years ago I'd be given basically the same slides that I gave 30 years ago, I think I would have just opened a bar or something like that, opened a brewery. I did take a break for about 10 years, most recently, and didn't think about this stuff, but I've been thinking about it a little bit more. I think it's interesting how the sort of use cases and scenarios have evolved significantly over that 30 years from, John talked about simple programs doing simple things through to people want to run big, complicated enterprise systems in these environments. And my view is, I'm going to start off with a very positive slide, but I think there are still some challenges. My view is we need to take a step back and think about exactly how to apply these technologies for the new scenarios and use cases. So here's my positive slide as to where I think we're doing really well in this community. And it's variations on the theme of is my app running unmodified on a good platform? So in this case, the sort of relying party, the person who's trying to find out whether the app has been modified and whether it's running on a good platform is the sort of same as the publisher. And that makes certain things much more simple. And we can go in the next couple of slides to think about a little bit more about how, how these broader use cases make things more complicated. So where are examples where I think this is working well right now? Now I've highlighted 3. There are more, but I've highlighted 3. The first one is in the data center, attestation and these technologies that John was talking about is used very extensively to make sure that your trusted computing base is really what the cloud operator wants it to be. So computers have gone from being relatively simple things with a CPU, which run an operating system, to now having, a dozen field updatable programmable components in them, everything from GPUs to graphics cards to various accelerators, networking equipment. And these are now all part of your TCB, and they all run firmware from vendors and from cloud operators and stuff like that. And you really, really want to be sure that that firmware is what you want it to be and hopefully doing what you want, expect it to do. So confidential computing, these building blocks are widely used for those scenarios. I recently left Microsoft, but certainly in Azure, we basically won't buy hardware for the data center unless it supports these confidential computing primitives, at least these attestation primitives. So that's one success story. Next success story is perhaps surprising even to people that are work in this space, is that all mobile phones now have confidential computing primitives built into them. Now, there's sort of 2 parts to confidential computing, which I'm going to cover in the next slide. There's the attestation and sealed storage part of it, and then there's the enclave part of it. Mobile phones mostly do the former. So they provide you with cryptographic evidence that your application is running unmodified on a non-rooted phone. I think this was largely originally delivered for things like anti-game cheating. If you're running mobile games, you don't want bots, playing with you because that destroys the fun of the game. So we have technologies called Play Integrity in the case of Google, and I think App Integrity in the case of Apple, which are attestation primitives to enable this. And the third one I want to highlight is in the data center. We are beginning to see, or data center operators are beginning to see, applications and scenarios using this technology for high value problems like financial services, genetics, I think is one of them. There are a few things that we're beginning to see. But I want to highlight in this case that the commonality of these things is the scenario is the relying party is the same as the app publisher, and they want to make sure that their code is running unmodified. So that's what I think is going well. And the next 3 slides is what I think, I should say, in addition to what John talked about ease of programmability and easy to make these things easy to use, but sort of what keeps me up at night as to what I think we need to do as a community to make these technologies scale to the next set of scenarios. So the first one is from trusting my app to trusting your app. So this illustration on the left is what I was just talking about on the first slide. I'm an app publisher. I distribute my app to a platform that I'm not completely sure I trust because I don't trust the operator or I don't trust the owner, but then I want to make sure that the app is what I think it is running on the platform that I think it is. But of course, A much more exciting set of scenarios, which we're talking around in this workshop today, is when you have a bunch of relying parties that are all working together, relying upon the same application. So now you have an app publisher, which may be different, but now you have 4 people that all want to share data with this app and have some confidence that this app is not going to leak their private data to the rest of the world or to each other. And so the issue here is, there's a deep question here, which I think Fred started to ask, and I think another speaker started to ask to John, which is, what happens if your program has bugs? Does this make any sense any longer? In particular, the question, knowing what an app is not the same as knowing what an app does, because it might have bugs in it, or because it might just be too complicated to analyze. So you know what the hash of the program is, but you still don't know whether if I give it some data, it will sort of honor my data access restrictions. So will my data be protected? As John said, most of the successes, or a lot of the successes have been in simple programs where you can do that. Knowing what it is the same as knowing what it does. But there are challenges as we scale. Okay. So a variation on this problem is illustrated in this slide here. And I want to talk about it in the context of sort of 2 sort of extreme examples of what people are doing with confidential computing platforms. The first is the example I gave of the mobile phone. You sort of have a root of trust. It boots an operating system, which has some good security properties, and then you run apps. And when you get an attestation from this thing, you're basically finding out everything that's running, on your platform in the TCP. So the nice thing about that is it's sort of a rich and familiar app model. Everyone knows it. Everyone knows how to write a mobile phone app, and you can sort of add attestation to it relatively quickly. The problems are 3 of them. The first thing is you must trust the operating system administrator. For general purpose edge devices like PCs running Linux or Apple or Windows, that's not necessarily the case, right? You have a powerful administrator that can make arbitrary changes to the app and the operating system. And of course, there's a huge TCP here. So the other sort of extreme example of how confidential computing is getting deployed is illustrated on the right-hand side here, which is you have some magical firmware provided by your CPU vendor, which can instantiate an enclave, was one of the early terms, which your app can run into. But there's a ton of highly privileged software, like a rich OS, they call it, that's also running on the platform that does not necessarily need to be trusted from the perspective of integrity and confidentiality. So the challenge, the good things about this is your TCP, your app TCP is much smaller. You don't need to touch the rich OS, but there are some challenges that come along with this. So one is that an enclave is not like Linux. So you typically need to do a bit more work to get your application to run securely in one of these environments. And often because you don't have as rich a set of services available to you, the app needs to do more to make itself secure. Like if you write something to the disk, maybe I have to take care of encrypting it before I write it to the disk, as opposed to if I was running on Android and I write to the disk, the OS takes care of that for me. So these are 2 sort of extreme examples. The actual truth is somewhere in the middle. All of these platforms have middleware, but I think it's illustrative to take those 2 extreme cases. So I would say, one challenge for the community here is how can we get the best of both worlds? How can we get the effectively small TCP solutions, but are easy to use and easy to adopt for non-security professionals? Okay, last slide here is attestation is a pretty coarse-grained thing, right? It tells you what program you're running, maybe what OS you're running on. But when we're thinking about data governance in an environment like this, we're often more concerned about, I've got a row in my database table or a little piece of data that I want to attach an ACL to, which says who can read it and who can't read it. And so there's sort of a big gap between the primitives that confidential computing gives you and the what people actually how they want to protect their data. We're good at protecting channels. We're not very good at fine-grained access control. So I think another job for the community is to think about, we have all this extremely powerful hardware, very widely available, but let's see whether we can get these mechanisms closer to the problems that people that worry about their app data being leaked require. Thank you.